This is my Lab 11 for Physics 2211. The main purpose of my lab was to explore an inelastic collision between two tennis balls in space, so no friction or low friction, and basically explore some other types of collisions using my model. So here's the video. The change in time was 0.033 between each frame. The length I used was the diameter of a tennis ball, 0.0767 meters. My x-axis was along where the first tennis ball was moving. So for my model, I had two balls, two spheres, and I set the mass to be the same for each, so 0.058. And for one, I set the velocity 0.4179, which I determined from the video by taking the change in position over change in time, and since there was no change in force, that's the velocity, the initial velocity. And for the second one, velocity is 0. And the position was 0.170, determined from the video. So for my model, I simply updated position of both balls every iteration, and I checked if the positions were less than the radius of one of the balls times 2. So if the centers were a diameter away from each other, the balls were colliding with each other. So if that was true, I took the total momentum and divide by the sum of the two masses to get the new velocity for each ball, which is the same in an inelastic collision. So if we run this, you can see the two balls collide with each other. They both go down to the same velocity, which is what we expected, and they go in the same direction. So if we compare this with my model and my experimental data, you can see that the blue, which is my model, compared to the red, which was the experimental data, they roughly follow the same pathway. There may have been some change in the z-axis that you can't see in the video, which would explain why the red is moving faster than the blue. So what if this collision, well, as we saw from the data, the velocity was essentially halved. So 0, it was halfway between 0 and the 0.4179. So velocity was half between when a ball collides inelastically with another object of the same mass. So what if this was an inelastic collision? I mean, a perfectly elastic collision. So we comment in this. This is simply taking kinetic energy to not change, and then also using conservation of momentum, you can get this equation for both velocities. So if we run this, you see that one ball, the initial ball that was moving, stops, and the other one continues at the same velocity as the ball that was moving before. Another thing we can explore is, what if the initial velocity of the other ball was moving in the opposite direction and the two balls collided inelastically? What would happen? Essentially, you take the sum of the two velocities and divide by the mass, and so this is only for balls of equal mass.